As discussed in the introduction to data transformation, one of the most important tasks when dealing with data sets is to create statistical summaries to calculate the mean and the median, standard deviation, and so on, in order to gain an idea about how the distributions of various variables varies. In order to do these calculations, we need to group the observations, since mean, etc. are statistical summaries. They're computed over several observations, which means we need to group observations together. And the dplyr group by verb allows us to group observations together. So let's say we wanted to see if there was a particular month of the year that was particularly bad for flight delays. And we could do this, we could answer this question by taking the flights dataset, piping it to group by, and grouping by month, and then piping this resulting tuple, which contains the group information, to summarize and computing the mean departure delay, which is the mean of the dep delay function. And we could also compute the mean arrival delay, which is the mean of the arrival delay function variable. And then we can just have a look at the stable, and we run into a problem. And the problem we run into is that we get a bunch of NAs for both the mean departure delay and the mean arrival delay. The reason for getting these NAs is that there are NAs in one or more of the 337,000 observations. There are some observations where the departure delay and arrival delay time isn't available. There's missing data, and the dataset contains NA to indicate that the data are missing, which means it's not actually possible to compute the mean over the entire set of observations. This problem can be circumvented using the na.rm argument to the mean function. And when we say na.rm is true, NAs are removed from the calculation of the means so that the actual mean can be calculated. And now when we run this code chunk, we get for each month from January to December what are the mean departure and mean arrival delays. And it seems like June and July and December have the longest departure delays. One could now ask the question, are these differences that we observe from month to month in mean departure delays, are these statistically significant or not? Meaning that, are the differences in the means bigger than the variation in the departure delays in each month? And so we would want to compute multiple statistical summaries. For example, we may want to calculate the standard deviation of the departure delay. We may also want to calculate the total number of observations that we have in each month. That is the number of flights we are calculating departure delays over. And this can be done since summarize can compute multiple statistical summaries. So we got the mean departure delay. Let's also get the number of observations. So the n function will count the number of rows or the number of observations in each group, and then we can get the standard deviation of the departure delay using the function SD. And once again, we should be sure to use na.rm to exclude NAs or missing data from the computation. And when we compute the means and standard deviations, it actually turns out that standard deviations are really quite big, compared to the differences in the means. Here the difference in the mean is like 14, but the standard deviation itself is 51. However, the number of observations is also very high, so this could turn out to be statistically significant even though the standard deviations are so big. So it would need a more fine scale statistical test to actually reach a conclusion about statistical significance. dplyr also provides a set of verbs for inspecting and interrogating groups. For example, slice head will provide the top n rows of each group. Slice tail will provide the last n rows of each group. Slice sample will give n random samples from the group. And slice min or slice max will provide n rows having the biggest values of the column X or the smallest values of the column X, depending on whether the function is slice max or slice min. So let's try these functions out. So let's take flights and we will group by month as before. And now if we use the slice max slice head with n equals 1, which is actually the default value, we get 12 rows, which means it's giving us for each group, which is there are 12 groups, one for each month, it's giving us the first row of each group, which is basically the first flight that happens to occur in that month. You can see it's always the first of the month. We could use slice tail, and now it will give us the last row for each month or for each group. And you can see the days are 31, 28 for February, and so on. If I change this n equals 2, you will see that instead of 12 rows, we will get 24 rows, which is the last 2 rows of each group. Here they are. They're both 31st January for January, 28th February for February, and so on. If we did slice sample, this is analogous to the sample function where we can sample a vector. Here we will be sampling each group randomly, so it'll pick one row at random from each group and show it to us. And now you can see the days are neither the first day or the last day of the month. There it's some random day because it's picked a particular row at random from each group. And we could do slice max. Now we have to give a column that we want to look at. So it will show us, for each group, it will show us the row which has the maximum value within that group for that column. So we could do, for example, departure delay. This would tell us which is the flight in each month that had the biggest delay. And when we do that, you can see, for example, in July, the flight with the biggest delay happened on the 22nd of July. its scheduled departure time was 4 p.m. and its actual departure was 8:45. This means it must have actually been scheduled to depart the day previously, and the departure delay is 1005 minutes. Similarly, I could do slice min, and this would give me the smallest departure delay for each month. And you can see they're all negatives, which means the flights with the smallest departure delay actually left early, roughly 20 to 30 minutes early in each month. So this is a way of, if you have a large data set, to get some idea about what is the biggest value of something in a group, the smallest value of something in a group, or look at the first row or the last row, and so on and so forth. Finally, in grouping verbs, we can create groups with more than one columns, as we did in the Introduction to Data Transformation video. And what this does is it looks at all the possible combinations of those variables in creating the groups. So we can take the flights dataset, pipe it to group by, and let's group by year, month, and day. So it will create all the possible unique combinations of year, month, and day, and group all the observations for these unique combinations, for each unique combination together. In other words, it will create groups for each day in the year 2013. Now, when we summarize a group table which has which is grouped according to a combination of two or more variables, it has a particular behavior where it will drop the last group. So for example, if I do mean departure delay, and of course I have to use na.rm to make sure that NAs are excluded, and then I can also add a column for the number of rows, number of flights. And when I run this table, it warns me that summarize has grouped output by year and month. So now this new table, that is the output of summarize, no longer groups by year, month, and day. It's dropped the day, so it's only grouping by year and month. So for instance, if I were to use the slice functions and look at the first row, I only have 12 rows, and that's because it stopped grouping by day and it's only grouping by month. We can change this behavior using the dot group argument, where if we say keep, it will keep all the groups in the original table. So now when we do this, there are 365 rows when we look at use slicehead to look at the first row in each group, which means there are 365 groups. That's because it's keeping the groups. We asked it to keep all the groups. Now, one interesting thing we could do at this point is try and determine, out of these 365 days, which day had the longest mean delay. So which day was the worst for flight delays. And since we already have the mean departure delay for each day, all we need to do is we need to arrange it, sort it in descending order. And so we are taking this tibble, which is the output of summarize, and then using arrange to sort it in descending order of mean departure delay. And therefore the first row of this sorted arranged tibble would be the day with the longest mean delay. And it turns out that the 8th of March was the worst day in the year, which had an average departure delay of 83 minutes. And the next highest delays, the average delays, were 56 minutes. So 8th of March was by far the worst day for flight delays for NYC airports.